Okay, number 43 from this section, which is 2.2, states that we should find the derivative of the function. So that's easy enough using the sum and product rule. Even though we have two functions that are divided by each other, we can still simplify this out to a point that we could use the sum and product rule. The way that we can do this is we have one denominator shared by two numerators, so we can rewrite this as the numerators separated by addition with the same denominator. And when we do that, we see that we get some cancellations here, right? So I get that this x cancels out with one of these, and this x cancels out with one of those. So I get that this is equal to 4x squared plus 3x. So my derivative of this with respect to x is going to be 8x plus 3. That's what my derivative is equal to. Alright, number 57 says to find the tangent line as if f of x is equal to 2 over the fourth root of x cubed when the function goes through a point of 1, 2. And the way they get 2 is they put the value of 1 into the function. So if I do f of 1, it will be equal to 2 over the fourth root of 2 cubed, which is 2 over the fourth root of 8, which is, let's see, a number that when you multiply it to itself 4 times gives you 8. That would be, oh, excuse me, that is, I'm sorry, not 2, 1. Let's see here, 1 cubed, which is 1, and the fourth root of 1, which is 1. So we get 2 over 1, which is 2. Sorry about that. So this 2 is they find it for you automatically, right? So our function does indeed pass through point 1, 2. So what is the tangent line that goes through the point 1, 2? Well, first we need to figure out what the tangent is. We can use this with the power rule, even though it looks deceptive, even though we have these roots here, right? So using some properties of exponents, we can write a root as x to a 3/4, right? We can make any root into a rational exponent, right? So we have x to a 3/4. Then another way that we can rewrite this function is using negative exponents, bringing whatever's in the denominator up to the numerator, or bringing whatever's in the numerator down to the denominator by just giving it switching its sign in the exponent, right? So now at this point we have something x to some power, and we can use the power rule. So our derivative of f of x is going to be equal to, well, we bring down that negative 3/4 and we subtract the exponent by 1. So this gives me negative 3 over 2. That 2 cancels out with one of those there. And then this is, alright, well, negative 3 over 4, and so that's going to be multiplied to x, so that's 4 over 4, so 4, 5, 6, 7, negative 7 over 4. And that is what my derivative is. So at a point x equal to 1, my derivative will be equal to negative 3 over 2 times 1 to a negative 7 over 4, but it doesn't matter. 1 to an anything is still just 1, so this is equal to negative 3 over 2. So if I were to have a slope equal to negative 3 over 2 that passes through a point of 1, 2, what is the equation of my line going to look like? So the equation of my tangent line, I'll use the little star there so we don't get confused that y is not equal to f itself or its derivative. It's just the tangent line. So my tangent line is going to be equal to mx plus b, where m is this negative 3 over 2. And my x value is 1, my b value is 2, or excuse me, my y value is 2. So then if I figure out what this is, 2 plus 3 over 2 equal to b, and therefore b will be equal to 4 over 2 plus 3 over 2, which is 7 over 2, equals b. And this tells me that my tangent line is going to be equal to negative 3 over 2x plus 7 over 2. So if I graph these two functions, and let's use this little online graphing calculator that we spotted at, let's see, where is it? gcalc, right? gcalc.net. Let's see here, where is it? No. Which one is it? No. That's that. I did that output. Oh, there it is. Okay, so our first function was, let's bring it up here so that I have it. Yeah. So our first function was 2 times x raised to a power of negative 3 over 4. So let's try plotting that. Pop, right there. Okay, so that's our function. And we want to know when it passes through 1, right? So let's zoom in a little bit, zoom in, right? Okay. So here is our value of x equal to 1, and here is our point. So now let's plot our function, negative 3 over 2 times x, which it represents our tangent line to the function at x equal to 1. So if I plot that, hopefully, yep, I get the tangent line, which represents the instantaneous rate of change for x equal to 1, the same rate of change as the function at one particular point that goes through the function itself. Okay, so that's number 57.